All right, question 76. Nina is buying a new pet fish. At the pet store, the fish tank has an equal number of two kinds of fish, tetras and guppies. Each kind of fish comes in four different colors, yellow, orange, blue, and silver. There are an equal number of each color of fish in the tank. So part A, if Nina scoops out a fish at random, what's the probability that she will scoop out a silver tetra? Show how you decided. All right. Let's see. I think here's what I'm going to do. I'm going to do a tree like we did yesterday. So here's what I'm going to do. I'm going to start here. And so I have two types of fish. I have tetras and guppies. So I'm going to start my tree here with tetra. And my other type of fish that I can get is a guppy. Guppy is with a Y, I guess. All right, let's see. Each fish can come in four different colors, yellow, orange, blue, and silver. All right, so if I have a tetra, I have four different colors I can get these tetras in. I can get them in yellow, orange, blue, and silver. If I have guppies, I can do that same idea. I can get them in four different colors. So I can get them in yellow again, I can get them in orange, I can get them in blue, and I can get them in silver. So this is all my possibilities that I have going on. So the question is this: if Nina scoops out a fish at random, what's the probability she will scoop out a silver tetra? Well, if you remember from our tree, these outside branches, these are all the possible things that could happen. A yellow tetra, an orange tetra, a blue tetra, a silver tetra, a yellow guppy, an orange guppy, a blue guppy, and a silver guppy. So I have 8 different things that could happen. So that's the bottom of my fraction, 8 different things. Out of those 8, how many of them are silver tetras? Well, that would be this right here. So we have a 1 in a chance of getting a silver tetra. Show how you decided. Well, this is how I decided on this. Okay, so hopefully that makes sense. Let's go on to question B. And question B says this: Nina set up the table below to organize the different possible outcomes. She represented the kind of fish on one side of her table and the color possibilities on the other. So here's the type of fish. Here is our colors up here. What do the fractions inside of her table represent? So they're talking about these things inside. They want to know, what do these represent? And I'm going to say that these represent the probability of getting a yellow tetra, the probability of an orange tetra, the probability of a blue tetra, and then a silver tetra. And then same thing down here. All right, so these are the tables that we did a couple days ago. Part C. As Nina looked at her work, she noticed that her table looked a lot like a rectangle with the area divided into parts. So this kind of, what they're saying is, this kind of looks like our generic rectangle. All right, where we had something like this, and we could do like 2 and 4 and 3 and 6, and that would mean the area of this rectangle is a 6, the area of this rectangle is a 12, the area of this one's a 12, and the area of this rectangle is a 24. So generic rectangles have been using for a while, that each of these pieces represent an area of the bigger piece. And if I were to add up all 4 of these areas, then that would give me the area of the big rectangle. So that's what they're saying. She says that it looks like a rectangle divided into parts. Get me out of the way. Could that help me calculate the probability, she wondered. So she used the length and width of the silver tetra. She used the length and width of the silver tetra section to set up this equation. So it's 1/4 times 1/2 equals 1/8. Well, 1/4 is this. Notice the colors. There are 4 different colors. We're looking at silver tetra. So of the 4 colors, one of them is silver. So that's where the 1/4 comes from. Then she times that by 1/2. Well, if we go down this way, my fish, there are 2 types of fish. One of them is a tetra, which is this one here. So that's where this 1/2 comes. So really what they're doing is like our generic rectangle over here, we have 1/2. So it's kind of like this. So each of these is 1/2. Each of these up here is 1/4, just like our generic rectangle. All right, so what they're saying is I could find the area of this rectangle right here by multiplying this length by this width. So 1/2 times 1/8. And when I do that, I get 1/8. So the area of this box would be like a 1/8. How does this equation relate to the length, width, and area of this section of the rectangle? Well, length times width, 1/2 times 1/4 gives me 1/8. Does this match up with the probability that we found in A? Yeah, remember we said that the chance of a silver tetra is 1 out of 8. So they're using this table and thinking about it as a generic rectangle. 4 colors, silver is one of them. So this piece is worth 1/4. 2 fish, tetras are 1 out of the 2, so this little piece is 1/2. And then to get this section right here, which is the silver tetra, we take the 1/2 times the 1/4, and we get 1/8. What is the area of the large rectangle? So what they're saying now is, what would be the area of this whole big rectangle? Well, you could do an eighth plus 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 an eighth, which would give you 8/8, which is 1. Or, since this is all the possibilities of fish and their colors, wouldn't that be 100%? So this would be the whole area. This would be all the possibilities of the color and fish. Lots of stuff going on in this problem. Hopefully it made sense. If I went a little too fast, don't be afraid to go back and rewind and go back through parts of it. But what they're doing is comparing this to our generic rectangle. When we're doing probabilities, I like doing the tree sometimes because it gives us all the possibilities on the outside branches. And then we can see which of the branches that we want to talk about.